Hello everyone and welcome to the Backend Masterclass. In this lecture, we will learn how to set up a Kubernetes cluster using Amazon's Elastic Kubernetes Service or EKS. Okay, but what is Kubernetes? Well, Kubernetes is an open source container orchestration engine for automating deployment, scaling, and management of containerized applications. Basically, a Kubernetes cluster consists of two main parts. The first part is a set of worker machines or nodes that run your containerized applications. Specifically, in each worker node, there's a Kubernetes agent, which makes sure that all containers are running properly inside a Kubernetes pod. Kubernetes supports several container runtimes such as Docker, Containerd, or CRI-O. There's also a kubeproxy component, which maintains network rules on the node and allows network communication to the pod. The second part of the cluster is a control plane, which runs on the master node. Its responsibility is to manage the worker node and pod of the cluster. The control plane consists of several components with different roles, such as the API server, which is the front end of the control plane. It exposes Kubernetes API to interact with all other components of the cluster. The persistent store etcd, which acts as a Kubernetes backing store for all cluster data. The scheduler, which watches for newly created pod with no assigned nodes and selects the nodes for them to run on. The control manager, which is a combination of several controllers, such as node controller, which is responsible for noticing and responding when nodes go down. Job controller, which watches for job or one-off task, then creates pods to run them. Endpoint controller, which populates the endpoint object or joins several services and pods. There's also a service account and token controllers, which create default account and API access token for new namespace. Finally, if you deploy your cluster on a cloud service such as Amazon Web Services, then there will be a Cloud Controller Manager component, whose responsibility is to link your cluster into your cloud provider's API and separate out the components that interact with the cloud platform from the components that only interact with your cluster. It has a node controller for checking the cloud provider to determine if a non-responding node has been deleted or not. Root controller for setting up root in the underlying cloud infrastructure. And a service controller for creating, updating, and deleting cloud load balancers. Okay, so that's a quick overview of the Kubernetes cluster's architecture. It seems quite complicated and has a lot of components, especially in the control plane. So setting up all of these components and maintaining them after that sounds like a bit challenging job. And that's why Amazon EKS comes into play. Amazon EKS or Elastic Kubernetes Service is a managed service that makes it easy for you to use Kubernetes on AWS without needing to install and operate your own Kubernetes control plane. So basically, the master nodes are automatically deployed and managed for you by AWS. What you have to do is just adding worker nodes to the EKS cluster, then connect to this cluster using your favorite tool such as kubectl, and use it to deploy your application. Alright, now let's learn how to create a new EKS cluster and add a worker node to it. On the left-hand side menu, let's select Amazon EKS Clusters. Then click this Create Cluster button. In the first step, we have to give a name for our cluster. I'm gonna call it Simple Bank. Then select the Kubernetes version. Normally, you should choose the latest one. In my case, it is version 1.20. Next, we have to select a cluster service role, which is an IAM role to allow the Kubernetes control plane to manage AWS resources on your behalf. We don't have any role with enough permissions that qualifies to be a cluster service role yet. So let's open the IAM console to create a new one. Okay, let's click the Create Role button. Select AWS Service, EC2 use case, then choose the EKS service in the list. Now we will see the EKS cluster use case here. Let's select it and click Next Permissions. Here in the list, there's an Amazon EKS cluster policy, and this policy contains all permissions we need for our cluster. So let's click Next Tags. This step is optional. You can add tags if you want to make it easier to manage your AWS resources and their budgets. For demo purpose, I'm just gonna skip this step. Now we have to give this new role a name. Let's call it AWS EKS Cluster role and click Create Role. Then voila, the role has been successfully created. Let's go back to the EKS Cluster creation form. Refresh the role list and select AWS EKS Cluster role. We also have an option to encrypt Kubernetes using KMS or adding text to our cluster, but I'm gonna skip it for now. Now we move to the second step. In this step, we will specify the networking properties for the cluster. We can choose the VPC to use for the EKS cluster resources, and also the subnet in your VPC where the control plane may place elastic network interfaces or ENI to facilitate communication with the cluster. Here the default VPC and subnet are already selected, so I'm just gonna use them. You should create new VPC and subnet if you're managing multiple EKS clusters. Next, there's an input field to choose security groups to apply the ENI that are created in the worker node subnet. But we don't need to specify anything because we will handle that later when we set up the worker node. For now, we're just setting up the master node for the control plane. So let's just leave it empty. There's also an option to configure Kubernetes service IP address range, but it's also optional, so let's not enable it. Now comes one important thing. Configure access to the Kubernetes API server. If you choose public, then the cluster endpoint will be accessible from outside of the VPC, and even your worker node traffic will have to leave the VPC in order to connect to that endpoint. I think this is not a very good option. The second option is both public and private, which means the cluster endpoint is accessible from outside of the VPC, but your worker node traffic to the endpoint will stay within the VPC. The last option is private, which means everything will only be accessible within the VPC. This is the safest settings that you might want to use in a real production cluster. In my case, I will choose the moderate option, which is both public and private, because I want to access the cluster endpoint from my local computer in order to set up the tools and deploy the application for the first time. After that, we will also learn how to deploy the app automatically via GitHub CI. Okay, here we have an advanced settings to configure some specific IPs that can access the cluster's API endpoint. By default, it is open to all traffic from anywhere. You can change it to only allow your IP address to access the cluster endpoint. That will be more secured. For this demo, I'm just gonna leave it open for all. Next, we can configure some add-ons that provide more advanced networking functionalities to the cluster. First, the VPC CNI to enable port networking within the cluster. It is using the default version 1.7.5 at the moment, but the latest one is 1.8, so let's change it to this latest version. The core DNS add-ons will enable service discovery within the cluster. It's already running the latest version, 1.8.3. Finally, there's also a kube proxy add-ons that enables service networking within the cluster. It's also running the latest version, 1.20.4, so everything looks good. Let's click Next to move to the third step. In this step, we have the options to enable logging for each of the components of the control plane. If logging is enabled for a component, then all the logs of that component will be sent to the CloudWatch log service. If this is a real production cluster, then you probably want to enable logging. But for this demo, I'm just gonna leave it disabled. Alright, now comes the last step, review and create. So to summarize, we have configured the name, version, and IAM role for our cluster. We're using default VPC and subnet for the networking, and allowing both public and private access to the cluster API endpoint. All the networking add-ons are using their latest version, and we don't need control plane logging at the moment. Everything looks good, so let's click Create. Okay, the cluster is now being created. It will take a few minutes to complete. So I'm gonna stop recording now and we'll come back when it's done. Alright, it's been a while, so let's refresh the page. The status is active, so that means the cluster is ready. We've successfully set up the control plane or master nodes for our SimpleBank cluster. Now we have to add worker nodes to it. The worker node will run in groups, which means a collection of EC2 instances of the same type. Let's click this button to add a new node group. First, let's give it a name, SimpleBank. Then we have to select an IAM role for the node group. This IAM role must have some required permissions to be qualified. That's why we don't see the role that we've created before in this list. So let's go to the IAM console again to create a new one. Let's click Create Role. Again, we will select AWS service and EC2. But this time, no need to select a service like before. Just click Next Permissions. We will select the necessary policy ourselves. Let's search for EKS. The first policy a worker node needs is Amazon EKS CNI policy. This policy provides Amazon VPC CNI plugin the permissions to modify the IP address configuration on your worker node. The second policy we must select is Amazon EKS worker node policy. This policy will allow the worker node to connect to the EKS cluster. Okay, now there's one more policy we would need to access the ECR repository. Because we're storing our Docker image in ECR, so the worker node will need access to ECR in order to pull the images. It doesn't need to push images, so let's just select Amazon EC2 Container Registry read-only policy. And that will be it. We only need those 3 selected policies for the worker node. Let's click Next Tags. Again, this step is optional, so I'm gonna skip it for now. In the final step, we can see the list of 3 policies that we've just selected. Now we need to give this role a name. I'm gonna call it AWS EKS Node Role. Then click Create Role. Okay, the role has been successfully created. Let's go back to the Add Node Group form. Refresh this list of IAM role. Then select AWS EKS Node Role from the drop-down. There are some options to set up launch template, Kubernetes labels, Kubernetes tent, and tags for the worker node. But we don't need to add them right now. We can always add them later once the node has been created and joined the EKS cluster. So I'm just gonna go to the next step. In this step, we will choose the configuration for the node machine. First, the Amazon machine image. There are 3 options here, but I think normally we would use Amazon Linux too, unless you want to have GPU enabled or using an ARM instance. Next, the capacity type, which can be on-demand or spot instance. Spot instance is usually cheaper than on-demand instance, but it can be interrupted at any time, so I think it's not stable enough to run web service API for Simplebank. On-demand instance is a safer choice here. Next, we can choose the instance type with different size of CPU, memory, and network interfaces. By default, T3 medium instance is selected, but we can choose another type of instance if you want. Let's say I'm going to choose T3 micro for now. For the disk size, I think we will need no more than 10 GB. Next, there are 3 options for group scaling configurations. First, the minimum size or the minimum number of nodes that the group can scale into. I'm going to set it to minimum of 1 node. Then the maximum number of nodes that this group can scale out to, let's say 2 nodes. And finally, the desired number of nodes that the group should launch with initially. I'm going to set it to just 1 node. Next, we can change the node group update configuration. For example, we can say during a node group version update, there should be at most 1 node to be tolerated. Alright, now let's move to the next step, specify networking. Here we can select the subnet in the VPC where the node will run. The default subnets are selected by default, but you can also create new subnets for the node group if you want. There's also an option to allow remote access to the node. If you enable it, then you need to create a key pair and use it to access to the node via a command line tool. But normally I would say we don't need to do so. I think we can fetch almost all information of the node we need via the control plane's API server. So I'm going to disable remote access to nodes. And just click Next. In the final step, we will have to review all the configurations one more time to make sure they're correct before clicking the Create button. And voila, the Simplebank node group is now being created. It will take several minutes to be fully completed. For now, there are no nodes in this group yet. But if we go back to the EKS cluster page, we can see that the node group has already been added to the cluster here, although its status is still creating. After a while, we can refresh the page, and now its status has changed to active. which means it's ready to run containers. If we follow this link to the node group page, we can see its configuration, like the minimum, maximum, and desired size. And in the Nodes tab, now there's already one node in ready state. That's because the desired size is 1 as we set up before. So it works. Excellent. Now before we finish, there's one thing I want to show you. That is how we can scale up and down the nodes. All we have to do is to click this edit button, then change the desired size to 2 nodes for example, and click Save Change. It will take a while to complete, but we will see the update history here with the status in progress. Now while waiting for it to finish, let's follow this link to access the auto-scaling group of this EKS node group. Now if you open the Activity tab, you can see the first activity that says launching a new EC2 instance. That was when we first created the node group and set the desired capacity to 1 node. Then after that, there's another launching EC2 instance activity because we've just increased the desired capacity from 1 to 2. The activity is successful, so now if we go back to the node group page, we can see there are 2 nodes instead of 1 as before. So the node scaling up works. So let's try scaling it down. I'm going to set the minimum size to 0 nodes, then set the desired size to 0 nodes as well, and save the change. Okay, let's go to the auto-scaling group to see what happens. There are 2 activities that say terminating EC2 instance, and they all have the mid-terminating lifecycle status at the moment. This means that the 2 instances are being terminated. That's because we have updated the desired size to 0 before. After a while, when we refresh the page, the activities will be successful. Then it means both instances have been terminated. And if we go back to the node group page, we will see there are no nodes in this group. So the scaling down feature also works very well. And that brings us to the end of this lecture. We have learned how to set up an EKS cluster and add worker nodes to it. In the next lecture, I will show you how to access it from local computer and deploy our simple bank application to it. Thanks a lot for watching, and I will see you very soon.